You ever wonder what it all means? Ah! Ah! What? Why, hello there. I am Shannon's the Potato, and welcome to my YouTube channel. Now, if there's anything I love in this world, it's physics, as you can probably tell since I've made quite a few videos on it. But the reason I love physics so much is because it can solve literally any problem that you have. And when I say any problem, I mean any problem. For example, unruly child, physics textbook. Angry criminal trying to rob you at gunpoint, physics textbook. Performing open heart surgery on an unruly patient, physics textbook. It works every time, guaranteed. But with all that brings me to the actual topic of this video, which is quantum physics. And no, quantum physics is not boring. It is really cool, and I'm going to show that to you, but it's also really annoying, which is why I kind of hate it. And that is the topic of this video, which is what I'm going to get into. But this then begs the question, what the hell even is quantum physics? And that is what I'm going to answer in the next part. Now, why the hell am I even doing a video on quantum physics in the first place? Well, there's the fun part. You see, I've been doing some work trying to prove Erton theory correct, and while doing it, I eventually came across something which seemed probable, but then I realized I had actually disproven my theory, which was very devastating to say the least. This led me to put Erton theory to the side for a little bit, but after getting some inspiration from my good friend who also runs a little channel called Jercew, which you should definitely check out because it's really cool, I decided to do quantum physics. Alright, so before I get into what quantum physics actually is, first I need to explain what, well, quarks actually are. Now, you see, everything is made up of atoms, which we know, and those atoms are made up of neutrons, protons, and electrons. And those protons and electrons also have building components, and those building components are quarks. Thank you for that piece of information outside, Shane, but since you're freaking stupid and deleted the clip between this clip and the last clip, I'm gonna have to improvise here. Alright, so this is what's going on inside of a proton. In this proton, there are 3 quarks, 2 up quarks and 1 down quark, and in between those quarks, there's little tiny particles called gluons, which hold the quarks together and thus hold the proton itself together. Protons and neutrons are both something called fermions, which means they're particles that make up of matter. They're fermions because they both have half-integer spins, and because they have half-integer spins, that means they obey the Pauli exclusion principle. The Pauli exclusion principle essentially states that 2 fermions, or 2 particles with half-integer spins, cannot occupy the same state at the same time. So 2 protons want to be in the same place at the same time, they are going to scatter into nothing faster than your dad after getting the milk. Now, unlike your dad, those protons aren't actually going to completely disappear, and that would be disobeying the laws of physics. They're just going to break down into smaller particles. But this situation would really never happen anyway because there's a repulsive force which keeps those protons from ever interacting with each other. And 99% of those time, the protons are going to be inside the nucleus of an atom, so they're never going to touch anything anyway because they have a field of electrons preventing them from colliding with anything at all. Which is why this would really never happen, but if it did, that's what would happen. And there aren't just fermions, there's also bosons. Bosons, which technically aren't even quarks at all, they're, well, bosons. And bosons are energy particles, particles responsible for the fundamental movements of the universe. For example, photons, which transfer energy via radiation, since they themselves are radiation. There's also gluons, which literally hold things like protons and neutrons together. And there's also the Higgs boson, which is a little freaky. Not that kind of freaky. Then, of course, in these subclasses, there's also a whole bunch of different types of quarks, like, for example, strange, charm, muons, hell, even gravitons, which are technically theoretical. There is also leptons, which is a subclass of fermions, which is technically just electrons, but that's a story for a different time. With this, we move on to the next part. Alright, so with that over, take it away, Outside Shane. But much of that really isn't important for us to know now. Maybe I'll make a follow-up video where I'll explain more. What I want to go into next is specifically the funny physics of the quantum world, which is what I'm going to do in the next one. After that little explanation, I decided to make my way back to the lab, and as I did, I encountered a familiar individual in the path. After pondering what to do about this for a little while, I just decided to stare at him awkwardly and then walk away without saying anything. This would go on to prove to be a very serious issue, and as I made it home, I decided to take a nap, as all that quantum explaining definitely tired me out. But when I woke up, I saw a very unpleasant sight. Alright, so now it's finally time to get into the funny numbers of quantum physics. Now, I know at the start of the video, and for the title of the video, and in the thumbnail of this video, I all said that I hate quantum physics. Well, guess what? I lied. I don't hate quantum physics. But it is very annoying, and I'm going to explain why. Now, the reason that quantum physics can be very annoying is because of the uncertainty. And literally, the uncertainty, the Heisenberg uncertainty principle, is one of the equations used, which eventually states that the more that we know a particle's momentum, the less accurately we can determine its position, which is completely bonkers in classical physics, because if you know a particle's exact momentum, you should be able to tell exactly where it's going to end up. And it gets even more confusing because you get into things like superposition, which essentially states a particle is in multiple states at once until observed, in which it collapses into a singular state depending on the circumstances. Which, how the hell is that supposed to work? Physics doesn't just obey whoever's observing it. Physics is physics. It's written into the literal laws of the universe. You can't change it. Now, to be fair, most places express it as when observed, but it doesn't really mean observed. It more so means acted upon. So a particle is in multiple states at once until sort of influenced in a way in which it collapses into a singular state, which is more understandable, but it's still kind of bonkers going off the terms of classical physics. And another thing I found that was kind of insane when I was researching quantum physics was the Schrödinger equation. Yes, the guy who liked to shoot cats. It has a freaking I in it. The imaginary number I. You don't have imaginary numbers in freaking physics, I swear to God. Now, whilst I am slightly annoyed by how confusing quantum physics is, it doesn't mean I hate it. I actually really like it, and I think it's very cool researching it. And I had a really fun time looking into it, and I'm definitely going to apply it furthermore in the future. So, with all that said, that brings me to my final point, which is